Try and talk about direct indexing here. So usually like when we have an array and we need to look up something, we're going to have to iterate through the whole array to see whether that element is present or not, right? There's actually another way of doing it and achieving this in all of one time. Let's say we iterate through this whole thing once. So that's one O of n, right? That's nothing, right? So we do that and then we find the maximum value within that array. And we create an index or an array that is of size that max element, right? So if the max element is 15, we're going to create an array of size 15, right? So, and when we do that, we could do something like second time, iterate through this whole array second time, and then, okay, so we're at 12, right? So at the index 12, initially all of these are going to be zeros, right? There's going to be 0, 0, 0, 0. That's just how it works. In most languages, when you initialize an array, so an int array, it's going to be all zeros. And if you do a Boolean array, it's all going to be false initially. So initially, these are all zeros. And what we're going to do now is we're going to iterate through this. So we're at 12. We're going to go to the index 12 and then put a 1. And then now we're at 5, right? So 5, we're going to go to index 5 and put 1. And then 3, we're going to go to index 3 and then put 1. And we see another 3. So what we're going to do is go to index 3 and then increment it by 1. So this is going to become a 2, right? So, and finally 15. So that's how direct indexing works. You could do an int or you could just do a Boolean. So if you don't really care about the number of, like how many of these elements there are, you could just use a Boolean, right? Like you could just do, like for this, like for either of these, you could just do, let's say for this one, you could just do 12 true, 5 true, 3 true, and then 0 true, 15 true. And the same for this, right? Like if you don't care about the fact that there is 2 of the 3s, you could just do what? You could do like you could do, sorry, you could do 12 true, 5 true, 3 true, and then 15 true. So, and you don't, so like here you don't care about how many of the 3s there are. So something like that, right? So and same with the strings. With strings, when you're iterating through a string, right? Like at index 0, 1, 2, 3, at index 0 there is a, right? So if you do let's say this is the string dot char at 0, which is a, and then if you do plus a, that's gonna reset the, I'm sorry, minus a. This is gonna be equal to a 0, which is where lowercase letters start in ASCII, right? So that's how we're going to fill in this direct index. So we're going to iterate through the whole thing, and then you're going to do, so a minus a is going to give us 0. So here, let's just do the Boolean version for now. So we're going to do a true, or let's just do the int, because these are closer to this. So a minus a is going to be a 0. We're going to do 1. So b minus a is going to be 1. So at index 1, we're going to put a 1, and then another b, right? So we're going to go again to this index and then increment it by 1. So it's going to become a 2. And then we're going to go to the index a again, which is 0. We're going to do 2, right? So that's how it works, direct indexing. And the issue with direct indexing is, what if the with strings we're not going to have much of a problem, even if there is uppercase letters, a b, you could just do int direct of size 128, right? And in this case, you don't even have to do a minus a. You could just do a, because you have 128. That's like the whole, it covers all the alphabets and stuff, right? So but since like 26 is smaller than 128, so 26 is like the size of this is 26, n equals 26. That's how many alphabets, lowercase alphabets, there are. Yeah, so since this is smaller than that one, people mostly use this one and then do like let's say the letter is b minus a or z minus a. It's going to give you the integer equivalent for this one. So anyways, the issue with direct indexing is, when it comes to integers, right, there could be a integer that's like 1000000, right? That's a really large, that's a lot of space, especially if the array only contains something like 1, 2, and then 1000000, right? Like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Okay, let's say there's another 0. If it only has something like this is like a lot of waste, right? Like that's a lot of space for just this one right here, right? So that's the reason we use something called hash maps. Also, we use hash maps because we need, like, if you want to store strings instead of just alphabets or numbers, hash maps, they provide a way to do that. So let's look at how hash maps work real quick, right? Okay, so hash maps essentially are just like it's an array of array lists, and within that array list is of type pair. Pair is basically pair is like, you could do like, it could be anything. It could be integer, or like a string, integer. So this is equivalent of creating your own class. Let's say class X, and then we do int A, int B, So you could be like array list of type X, right? So like this would be similar to this, right? Like this would be similar to this. Not this one, not the string and integer, but this one right here. So that's the whole idea. Let me clear this real quick. So what we have here is an array, right? It's an array. It's a fixed size array, but that array is of type array list or linked list. So like linked list, and that linked list is of type X, or you could just do pair because it's built in. Yeah, so it is an array. So you know how we have int arrays? It's like instead of int, it's this big thing right here, and then you put the square brackets, right? So it's like that, and then so there's something called a hash function, right? So hash function is basically the element mod the size, and this is going to make sure that it's distributed evenly. And so essentially we're like for each element we're getting that mod, and then for that mod we're gonna if the linked list does not exist, if it's like a null, we're gonna create a new linked list, and then we're gonna if it's not present, right? Like, okay, so let's say this is not present in 2, right? So we're going to create a new pair, 12 and then 1, and we're going to add it to the existing linked list. So we are going to have to like each time we do this, so let's say 12 mod 5, it gives us 2, right? We're gonna go to 2, and then we're gonna iterate through the whole thing, O of size of the linked list. Okay, so and at each step we're gonna check whether this is called the key and this is the value. At each step we're gonna make sure we're gonna see if this is the key equals to what we are looking for, and if we do not find, and when we're trying to add something new, if we do not find what we're looking for, we're gonna append it to the end, at the end, like the tail, right? Like in linked list there's gonna be a tail. You just append it here. So, but if you do find something, right? So we're gonna do an example where something already exists, right? Okay, let's see. So we already did 0. We already did this one and this one. We're gonna do this one, right? So we're at 3, and then so we did this one and this one. We're at 3. 3 mod 5 is 3, and we're going to go to index 3. Okay, this is null. Well, let's create a new linked list that is of type pair, right? So we created a new one, and then we're going to add 3, right? And the count is 1. Okay, this is done. We're going to do this again, right? Like 3 mod 5 is going to be 3. We're going to go to 3 again, and since it's already present, we're just going to increment it by 1. So it's going to be 2, and this is done. So and you just keep going, and let's say we're at 13. 13 is also at 3, right? So we're going to go to 3 again. Now we're going to add a new node to the linked list, and it's going to be, okay, so we're done. Let's say we're done with this. Let's skip this one. We're doing this one right here. So 13 mod 5 is 3. We're going to the index 3. We're going to iterate through, and we have not found a node whose key is 13, right? We came here and then we saw the key is 3, not 13, and there's nothing else after this, right? So we're gonna create a new node, and we're gonna create a new key and value. So it's gonna be 13. We're gonna create a new pair. So like basically new pair or something like this, 13. We don't need the quotes, and then 1, because we just have 1, right? Okay, so that's basically how it works, hash map. And there is one more example for direct indexing, and it's try, right? But we're gonna look at this concept later, because I'm gonna make a separate video for it. Yeah, so that's about it for direct indexing and hash maps for now.